This meeting is being recorded.
Oh, cool. All right, welcome back to Crafting Interpreters in Rust. As Michael says, we're writing a macro abomination to do, which is basically like a tiny little parser generator. We are sort of done, but we're done with the interesting parts. The only things left are a few rules to pull out data of any tokens that contain data. So we've done one so far. We've done identifier. And we still need to do number and string. Then once we have done that, we haven't finished the parser. What we finished is a way to sort of abbreviate writing the parsing code. So we can sort of copy these and adapt them. And then we need to do, we need to write functions that turn the result of that into AST nodes. But it should go a lot faster once the macro is done. So let's do the final part of the macro. So we've got, let me sort of copy the identifier block because I think the other ones will have similar structure to that. So if you see, number, then you need to pull some stuff out of it. And same for string. And string contains, let's go and see how we defined number and string in the token type, The string just contains a string, number just contains a float. So both of these will get matched this way. Okay. So instead of ident, it will be value. I guess that's the numeric value inside. And I will say value for the string as well. And let me see, does any of this need to change aside from that? I don't think so.
Yeah, looks about right.
Yeah. Yeah. So let me see. Is there any other? Let me take another quick look at token type. To see if there's anything else that contains data. Yeah, those are the only ones that contain data. So those are the only ones for which we need special variants. And I suppose we could, if there's a rule to like combine a few of these, can you do something like that? Number. I don't think so.
You can. So we can shove them into, let's say, square brackets and merge them, not selection between all of them, but every one with a question mark. And as long as we're careful and put just one item inside square brackets, it should be.
I think I'd rather, I see what you're saying. I think we have like we have this kind of thing. Special token ident. And then that just maps to this rule instead of the other one. But
Yeah, that also
I, I prefer to just have 3 different rules so that we don't have to change the syntax.
Yeah, let's keep it simple.
Yeah. Okay. So that might be the end of the macro. I guess let's try to translate a few of the grammar rules. So the first one that we started with is this one. So by means of this builder function, we're turning a class decal, or we're making a thing called class decal, which is composed of these. Now let's see. Did we stick with the square braces for calling another parser? Let's see. So I don't really like that syntax.
We tried parens, and the conclusion was it doesn't really play nicely with expressions.
Okay. So we ended up with square brackets around the thing. So I'll do that. Okay. Now it says build function doesn't exist. Is okay. Let me fix this. So function goes to this. Does statement block not exist? Okay, we just made it. Yeah, we didn't make it exist yet. We just declared the statement type. Okay. So params. I guess I just need to pull it out of this. If there were parameters, then I'm going to put them there. If there were not, then empty vector for no params. So this contains what? The parameters needs to be a vec string global. Global means lifetime.
Global is we don't really need it. It's allocator.
All right. So what is this stack thing? It's a string and a vector of strings. So what is the string part?
Function name.
Did I just kind of print it out? I think we parsed the name out earlier. Yeah, name is the first string. I'm trying to think if there's like a faster way to work with this macro. because it just builds some stupid nested terrible type, and we need to like destructure it, and I don't know how.
Well, in
So-
Haskell, you would use monitor applicative functor or something like that. In BPath, I made a separate macro to deal with the construction.
Mhm. Okay.
We
So
can make-
basically just get used to it. I mean, so
Yeah,
all right.
we can make one more macro to deal with macro.
Okay, don't tempt me. Yeah, how would you even do it? I mean, like, you need to like name what the parts are that you're building.
It's mostly describe how you squash them together, I think.
Okay. So why is that? Okay.
I wonder if it would be easier to read the code that was generated.
Maybe. You mean like this one and then see what
Yeah.
we're returning?
Expanded.
Yeah. All right. Fine.
Actually, so we have the macro listed below, and only certain items produce something. So we have identifier name,
Mhm.
then we have identifier, com identifier. So
And the question mark affects it.
yeah, so
So this is the first identifier.
Statements, they are all parameters. They are comma separated one.
Yeah.
Params is the first one, statement is the rest.
Gotcha. So this is first parameter and then the rest of the parameters.
Yeah.
Okay.
What? Could you explain? So the second dot one is accessing.
This isn't right.
Oh,
So,
okay.
yeah. We're just decoding. So how this type gets constructed depends on the structure of the grammar role. So what we have here is an optional group, which has to have at least one identifier, and then any number of other comma separated identifiers. So because of the way we wrote the macro, this group with a star after it gets turned into a vector of other parameters. And then this gets turned into a single object, single string. And then the entire optional group becomes an option because it may or may not exist. So if we look at the type that we get coming in, it's a string, which comes from the first identifier. And then this nasty thing, a tuple of an option, string, vex string, whatever, that comes from this optional group. And then an option statement, which comes from us calling the recursive parser for statement. So,
Okay, thanks.
yeah. So in conclusion, this big mess that's inside the option is the parameters. So what we need to, and this is the first parameter, there, that's the first parameter. And then the vec of strings is the rest of the parameters. So we need to pull them out and put them in a list. So I wish I could, and all these unit types are coming from the base case.
Yes.
So is there any way to get rid of those? Or is it just not allowed by the structure of the macro?
It's not allowed by the structure of the macro, but we can probably add something like this base case specifically to get rid of it.
Mm-hmm. Yeah. It seems hard. It seems like a type level operation. I don't know how to do it. All right. So equals params. Let's see what it thinks those are. A string and a tuple of vectors of whatevers. So pull out other params like that.
That should go inside of the parents, I think. Yep. And instead of specifying underscore for unit, I would put the unit itself. This way, if we make a mistake or change it later, the type checker will complain.
Okay. Yeah, sounds good. So specifically, we are explicitly
Yeah.
we think that's a unit. Okay. Let's see. Do we have some kind of spread operator or something? I kind of forgot.
No. It's a vector. So we need to take other params as mutable. We need to apply map to drop the unit, collect the results into a new vector. No, we don't need math.
Yeah, I don't. Can I just construct a new one?
Yeah, but you cannot push. I was thinking just convert other params into a vector and then insert first param with insert at the
Okay.
0th place. That is not going to type check.
Mm-hmm. Oh yeah, we need to mute. Yeah. Okay.
Yeah, you need to tell that it's a vector.
So it can't guess based on. Oh yeah. Oh okay.
Now collect
Should
this.
it be able to guess based off of if I put it there?
Type
I don't-
checker in Rust is not very smart.
Fair enough. I don't know how type inference works. All right, so we expect them to be strings and instead they are references.
Type inference is relatively easy to implement, but in Rust they use a bunch of trait that gets selected by the resulting type, and this makes a lot of things harder. I would change it to owned inside the first map and inside the insert, just so we don't reallocate more than necessary.
Sure. Dot. So why doesn't it like that?
Because you specify, you can just put underscore there. It should be able to figure out what's needed.
That's fine. Right. Yeah. Okay. It's giving me an error somewhere in the macro. Okay, now it's giving me the right error, which is that I haven't declared anything like this. All right, cool. Cool. All right, so let's start filling out these rules, I guess. So we have the enum statement and the impl for statement. I'll move these where they should be. Okay, so a statement. Let's copy this whole thingy. And maybe format it. All right, so you should be that. For okay. That's Corinne. Okay, and then this is Grace. All right, and probably have to do some other stuff. Oh, there's a memory leak if you use collect.
Well, it's
Okay,
not
that
a
would-
memory leak. It's it will try to reuse the same allocation. And in that article, they've been reallocating from a big type to small type. And the capacity was hanging around.
Okay. Cool. Let me sort of do this kind of thing. All right, and we don't. I guess I'll just This one's formatted differently. It's multi-line. I guess. Okay.
Magic.
Uh, okay. This is the block of grammar rules for a statement. A lot of stuff is still wrong. I just wanted the help of the linter. So this is a parenthesized expression. Expression. Let's see, what's an expression? An expression is another type that I haven't made yet, I think. Oh, no, it exists. We just need to.
That's what we start
Yeah.
making the parser from.
Yeah. So every time you say expression, you should say square bracket expression colon expression. And that refers to the thing we're going to make. Okay. And every time you have a question mark, you need parens. Okay, it doesn't know what statement means. Statement means myself, statement. And declaration. Did I make a declaration class? Yeah, I did. I mean, not class, but you know. I got another question mark there. Okay. So this should be declaration, friends, and these are new things. Okay, so these are all just the other rules. So all of these, let's see, how should I fix this? Something like that. Okay, and then I guess I was just going to
Start making the builders.
yeah. Okay. This is satisfying. I want to keep doing these before I do the builders. So it'll be less fun. All right, so this is called an expression. Oh wait, no. Declaration var decal. And this is called an expression expert statement. Is there anything else here?
There is statement at the end of the for statement.
Great, thank you. Okay. Strip out this crap because we're about to replace it. Expressions. Same deal. All right. Sure I did that right. Okay. I forgot what all our names were for these. That one's a minus, say, plus. That's not right. That's right.
It's magic.
Yes. Okay. And bam. All right. Let's fix what we need. Greater equal less equal. All right. So what's a call? Call is another expression.
Same.
Let me see. Probably a lot of these are the same thing. So that and what's an arguments? I think that's one of his little, yeah, that's just like a little. So I'll substitute that for just this. Okay. All right, now I got to fix the parentheses and stuff. So assignment is, did something get messed up there? No, okay, it's fine. So that. Yeah, so just that. Okay, and then this needs parens about around the whole thing. And so is this, I think. The call is primary and then, okay, it's around the star group. Like that, I think. Okay. So I need to look at these side by side, I think. So call's gonna go to. Okay, a primary followed by any number of how'd that happen? Okay, all right, because this is arguments. So followed by a left paren, arguments right paren, or dot identifier, any number of them. Do I have the parens right? I think so. Left paren.
So the asterisk after the dot identifier, because that one, I was just checking if that's in the right paren. Because it
So
should be
or
around primary. Oh, okay, yeah, it is.
let's see. Do I need to? Okay, yeah, I think that works. So, oh yeah. Okay, that's a good point actually. So this is an expression. Yeah, the sub expression here, not terminated. Right? Or yeah. So common expression, any number of them. Just ended up with an extra paren. Okay, optional. That seems right to me. But Russ doesn't like it.
Primary.
That seems right. Maybe. So I wish I would stop recoloring my parens. So we need why don't I just rewrite this one? I'm confusing myself. So that is an expression primary. Or, and then we need another set of parens around this. because so that it parses the pipe, the OR group, and then parses the any number. And then we need to expand out what arguments means. So arguments means this. So we need a parens around that. For the optional group. And then I think we're good. And now I just need to replace the comment, the strings with what they actually are. Okay.
I would seem to be happier. I think what we want now is to comment most of it out so we can start dealing with them one thing at a time.
Do you want to write the builder functions or do you want to?
We need to think a little bit how we're going to deal with like plus or minus,
Okay.
because we don't really capture anything at the moment for them.
Oh yeah, you're right. You're right. We need to emit a different type of AST node.
Yeah.
So that means we need to record something about the token type, right? In just the generic token type rule.
Yep.
We need to record that.
Yep.
So
Well, it's going to be similar how we append stuff in other places, like how we extract name.
yeah, we just need to, we can't just simply continue on, I guess. But that means we're going to end up with a much more complicated type, right?
Yes, that is the problem.
Okay. So should we have two rules, one for like capturing the
Possibly.
token type and the other for not doing that?
Possibly.
Okay.
Or we can use like curly braces around stuff we want to capture.
Hmm. Okay. Okay. So the else case is still fine because it's the same error. The if case, we need to do something similar to what we did for this.
Yep. And I think you need to replace the value with $TT value on the next line.
Yeah,
And
just to
that's
pass the type in. Okay.
and sub3, yeah, just to keep things clean.
Yeah. Okay. Fun. So how do we, so can that go around this? We made it only work on like,
I think we need to go around bank and around minus.
yeah. Oh, annoying. What would it take to make it go around a recursive call to grammar rule? Probably a lot. Because we don't know that it doesn't always
Because-
produce just a single token type.
Yeah,
All right, I'll just do that.
it doesn't really go around a recursive call. It's we capture in this specific token,
Yeah, exactly.
not
Yeah.
the recursive part.
Okay.
With applicative functors, you just transform it into whatever shape you want and squash them together.
Hate this.
But in Rust, it's clumsy.
Does this ever apply if you don't have an OR group? Because we could make it part of the OR group macro, right?
We don't
No.
have it inside our group.
Yeah, because it's just one token.
Our group tries to run inner parser
Yeah.
and just picks the first one that succeeds.
Okay. Fine.
Not the string and not the number and not the identifier.
But I do need the first four, I think.
Yep.
Okay. Okay. What are you talking about?
We might need to split it at some point, like primary probably is not going to type check. Primary build.
Mm-hmm. All right. Can you think of anywhere else that we need that? The base a thing off the type of a token. So the only reason we needed to do that is because we're including this as a field, not the enum variant, right? Like the statement enum, for example, we're going to know which of these rules we matched and exactly how to parse each one of them based on just which variant of the enum we got at the end.
Yes.
So because these don't contain any data, we don't have to do anything with them. So let me see. So
They should have some data. Right now they don't.
yeah. But so the data will be all just pointing to other nodes. I think, right? AST nodes. Okay. All right. So it's a good call. So we just did expression, we've done statement. Now I need to do the rest of declaration. And then we can start doing builders. Okay.
So you want to finish grammar today and deal with the builders next time?
I suppose so. Yeah.
Okay, that works.
I guess, yeah, I do need a self, don't I? Yeah, I'll need to put that on all the other ones. Um, okay. Parentheses and stuff. Okay, this is these are all just the variants of me. Say function expression. Okay. Any other big blocks here? I think that's it. So that made a big mess. We will start building the builders next time, I suppose.
With the code in this state, would the expand still work, or would the errors
I
cause
don't
it not to
expect it to
expand?
work. I don't expect
Expand
it to
should
work.
work.
Right.
So it's giving me a bunch of. So expand does make, yeah, let's do that actually. That'll be fun. Yeah, I already ran that before, but. All right, so with the macro invocations, we are at 3,000 lines of code. And that's so it looks like this terrible mess. Without macro invocations, we are at 1,000 lines of code. So there we go. About we saved ourselves about 2/3 of the code we would have had to write, but we still have to do builders. So there you go. All right, that's a good stopping point, I guess. Macro's done. Now we just have all these stupid builders functions to write.
Yep.
Awesome.
Question, comments,
Yeah.
suggestions, wish list.
I guess the builders, so that's just going to be following along closely in the book.
No.
No, nothing like this exists in the book.
Okay.
The point of the builders is this macro spits out data in some crazy recursive format that the macro sort of ends up accumulating. What we need to do is turn it into an AST node. So figure out which pieces of the data we just parsed are which pieces of the AST. So the one that we have actually done is this class declaration one. The data is in this crazy format, and we happen to know that the identifier is this first string, and then this tuple contains the parent class name. And then so we can construct the class declaration node out of those pieces. So it'll be a lot of functions similar to that.
Okay, similar to, so looking at that before the next meetup.
Yep. Yeah.
Okay.
It'll be such a slog. I mean, or well, I don't think it'll be very interesting to watch that code being written. So I might kind of just do it. And
If
ask,
you encounter any interesting bugs, don't fix them.
yeah. Yeah, I'll bring up any interesting bugs on next meeting, but any uninteresting bugs I will fix.
Yeah, anything obvious.
Cool. Stopping the recording.